Good morning, everybody. Welcome back to the Workday Morning Show. I am your host, Tony Gilfillan, and I am joined, per usual, by Millie Doggy Brown. She's in a bitey mood today. All right, we're going to join us the way we usually do in the things that I find interesting in the world today. All right, Apple is going to be using Gemini to run its AI-powered Siri. Not a huge shocker, to be honest, because they're currently still uh, in a Apple uses Chrome as their kind of back end as well. So there's a lot of paid between these two companies, even though they're quite rivals. So not crazy shocker there, especially given Gemini's dominance in the LLM world today. This one was pretty interesting. Anthropic announced a Claude for healthcare following OpenAI's ChatGPT health reveal. So these are little, essentially, connectors to a bunch of different stuff regarding healthcare, and it does not use essentially users' data to train these models. So thought that was pretty interesting. Definitely, hopefully, going to help the penetration for AI into the healthcare world, for better or worse. Meta shut down over 500,000 accounts in Australia after a ban for the 16 and under. Governments, and obviously Meta's trying to get that to be reversed. Not crazy, honestly. I think this is kind of no nonsense legislation that probably America should start doing. Not a huge fan of social media in general, especially for the younger generations. It just leads to a lot of unsavory things. We have some Workday developer program update call news that is happening today in about an hour. So make sure you join us for that one. I'm going to drop this in chat. So anyone that is not signed up already, be sure to sign up. Not able to copy this. I can't copy and paste into my chat window here. I'm just going to copy it by hand the old fashioned way. lnkd.in slash b6 bt8 x9d. Got that right. Thank God for these short URLs. All right, yes. So if you haven't signed up, be sure to join us in about an hour over there. And last, I came across this neat little database for essentially checking your vibe coded code bases. So it has a whole slew of common vulnerabilities that vibe coding tends to produce. So this is pretty neat. I will drop this again in the description of this video. But it is basically 62 different vulnerabilities that LLMs commonly mistake into your code bases. I actually ran this against the 3D printer app that I was building earlier, and it found a variety of different things, especially in the APIs that I created that are basically vulnerabilities in that application itself. This little website here actually gives you a really quick generated prompt. So it's a really well written prompt that describes all of these vulnerabilities and how to evaluate them within your code. So let's go ahead and take a look at what that actually outputted before we jump over back to my Orchestrate Insights app. So I just copy and pasted from this site, this safevibe.vercel.app. You can select a variety of different vulnerabilities. So there's a bunch of them in here that you can select or deselect if they don't apply to your particular code base that you're building. But once you're done selecting what you need, It's going to tell you exactly how many tokens this prompt's going to use, so that's pretty cool. Then you just copy the prompt, drop it into your favorite LLM that you're using to vibe code, and then it's going to output all of the issues that it may or may not find. As you can see, there's a variety of things that it did find in the vibe coded version of this 3D printer app that we built. Some of these are more severe than others, but definitely interesting to see. So like it caught a password, it caught a bearer token in there. Let's see, some of the other ones that are pretty glaring are an infinite retry loop potential. That's no good. Yeah, I mean, this is just really handy tools, especially when, AI is so prevalent these days, to definitely check what those LLMs are cranking out and make sure that, you're closing any security gaps that may or may not be in place. So this is a pretty neat little collection of vulnerabilities that I'm definitely going to keep on my back burner for when I'm building stuff like this. So again, drop that in the description. You guys can feel free to use that. Alrighty, so let's jump over back to what we were building before. So we have the Orchestrate Insights dashboard app that I was building that also has a couple different orchestrations in it that utilize those Insights APIs. And then I also scheduled a integration that was from a separate app that we'll use to kind of leverage to show a little bit more verbose data once we get a UI version of this app up and running. Now let's go back to the dev site. We'll go ahead and open this in App Builder, and I'm also going to open both these orchestrations in their own window. So I really want to get an idea. Essentially, the whole idea behind this app is to get a broader idea of how my orchestrations are running, what errors they're running into, and ideally how to fix those errors. So the errors themselves, I definitely want to see if I can't surface more information within the UI, and I think I will be able to do that given the response from these Insight APIs. Putting too many things at once. Still seem to be having some lingering internet issues. Refresh all these. Website opens fine. What's wrong with the app itself? Just this app. And get around the dev site just fine. Open up printer app. happening? This is quite strange. The Insight APIs to see if having connection issues. VPN is deciding to reset right now. The most opportune time. Here's the APIs we're using. These work, right? Connection seems fine. Having technical difficulties with just connecting right now. Not connecting. Oh goodness. Technology is fun. Well, while this is spinning and I'm fiddling with my internet in the background, let's take a look at... I created a little notebook LLM for quantum computing, just to kind of educate myself a little bit more on what exactly is a qubit. And it's a neat little video, actually. So we'll listen to that.
All right, let's talk about something that's poised to be one of the biggest leaps in technology, maybe ever: quantum computing. We're talking about a whole new way of thinking about calculation, one that uses these seriously weird, almost magical rules of the subatomic world to solve problems that are currently impossible. This could literally redefine everything.
But before we dive in, I want you to think about this question. Seriously, what kind of problem is so massive, so complex, that every computer on the planet working together couldn't solve it in the entire lifespan of the universe? This isn't just a fun thought experiment. It's a very real wall that we've hit, and it's the whole reason we have to build something new. So, to really get why the future is quantum, we first need to understand the limits of today. We need to see that wall we're running up against. It's not a small hurdle, it's a fundamental dead end baked into the DNA of every computer we have right now. You know, the language of your phone, your laptop, the servers running the internet, it's all based on one simple thing: the classical bit. Just think of it like a light switch. It can be on or it can be off, a 1 or a 0. That's it. Super simple, super reliable. And it's powered our entire digital revolution. But that simplicity is also its biggest weakness. And here is where that weakness becomes a full stop barrier. Take the encryption that protects your bank account, your emails, everything. It relies on a mathematical trick. It's easy to multiply two huge prime numbers together, but it's ridiculously hard to take that result and figure out the original two numbers. For a standard 2048-bit number, we're not talking hard. We're talking a classical computer would need billions of years to crack it, longer than the universe has existed. This isn't a problem we can solve by just building a faster computer. It's a fundamental limit of how they work. So, how in the world do you get past an impossible problem? Well, you change the rules of the game. You have to toss out the classical rulebook and start playing with the bizarre, mind-bending physics of the quantum realm.
Okay, so the first new rule is called superposition. This one's a trip. Imagine you flip a coin. While it's spinning in the air, before it lands, is it heads or tails? In a way, it's both. A quantum particle can do just that. It can exist in a combination of states, a little bit of 0 and a little bit of 1, all at the same time. It's only when we measure it, when the coin finally lands, that it chooses one definite state. And if you thought that was strange, the next rule is even crazier: entanglement. This is where you have two or more quantum particles that are linked in this deep, mysterious way. Their fates are intertwined. If you measure the state of one particle, you instantly, and I mean instantly, know the state of the other one. It doesn't matter if they're a millimeter apart or on opposite sides of the galaxy. This idea was so bizarre, so non-intuitive, that Albert Einstein himself famously hated it. He called it spooky action at a distance. He was convinced it couldn't be right. But guess what? Decades of experiments have proven him wrong. This spooky connection is very, very real, and it's one of the most powerful tools in the quantum toolbox. So we have these incredible new rules: superposition and entanglement. What happens when we build a computer component that uses them? Well, it's time to meet the star of the show, the hero of this whole story, the qubit. The qubit is the quantum version of the classical bit. But because of superposition, it's not just a 0 or a 1. It's a 0 and a 1 at the same time. And this is where the power explodes. Two classical bits can store one of 4 possible combinations, but 2 qubits can store all 4 combinations at the same time. 3 qubits can hold 8. A few hundred qubits, they could hold more possible values than there are atoms in the entire known universe. Now, as you can imagine, controlling this kind of power is an unbelievable engineering challenge. To get many of today's leading qubits to work, you have to cool them down to temperatures colder than deep space. We're talking 15 millikelvin. That's just a tiny fraction of a degree above absolute 0, the coldest temperature possible. And why the extreme cold? Because we have to protect the qubits from their greatest enemy: decoherence. See, these quantum states are unbelievably fragile. The tiniest vibration, a stray magnetic field, even a little bit of heat, can cause the qubit to lose its quantum magic and just collapse back into a boring old classical bit. The whole field is basically a race against time to perform calculations before decoherence ruins everything. So, despite all these crazy challenges, we are actually building these things, and they work. So, what's the payoff? What can these machines actually do that makes all this effort worthwhile? Well, the advantage is staggering. Remember that factoring problem that takes billions of years? A quantum computer could potentially do it in hours. Searching through a massive, unsorted database of 1 million items, it goes from 1 million steps down to about 1,000. And simulating complex molecules for things like drug discovery, it goes from literally impossible to actually efficient. We're not talking about a small speed bump here. This is a whole new dimension of computation. Let's look a little closer at that factoring problem, because it's so important. The quantum recipe for solving it is called Shor's algorithm. People call it the killer app, because when it was discovered, it showed the world that quantum computers weren't just a theoretical curiosity. They could solve a hugely important real-world problem that classical computers couldn't. It's the reason governments are taking this so seriously. And what's just around the corner? Well, right now we're living in what's called the NISQ era. That stands
All right, I'm going to try and see if I can't get this connected real quick. We got about 10 minutes left. Definitely having some firewall problems. Looks like I might have fixed it. Getting that come through. Finally see App Builder again. Perfect. And let's just the orchestration builder opening. Like it is. Perfect. All right. Well, that was unfortunate, but let's go ahead and truck on and create some pages here. I did find that little video. There's some weird AI hiccups in there for sure, especially with the graphics, but just found it pretty interesting on, how qubits really do operate and how kind of fragile they are in today's world. Let's see. So I'm creating a page here for this is the actual dashboard. Call this a little bit more descriptive. Orchestrate insights dashboard. All one word. Then we're going to eventually create. My mouse is being goofy today. Create an endpoint, a REST endpoint, because we're going to be getting data back from this particular API. Here is the API we're going to use. So when you're in Orchestration Builder, you can grab the actual URL for the API to hit this orchestration with just off this little orchestration settings button, and then down here is just your API URL. Copy that, go back to our endpoint. Can just drop this in here. I should probably create an AMD for it. That's what I'm going to do. And I like to steal from myself, so let's go back to apps. We did this. What else? And toolbar here. I know this one's got it. I go grab from an other AMD the code for those data providers. Yoink. Here. So the real one I'm focusing on here is going to be this orchestration one. This is just helping me save some time in referring to these URLs if I have to reuse them. This API gateway endpoint variable is just a handy way of resolving the actual gateway URL in your endpoints. If I go back to my page load here, I can just type in orchestrate, but I do need all this stuff. This is going to be hard coded for me. URL type is orchestrate. And that will pull from my data providers here, orchestration. I need to correct that. Orchestration. And then finish my URL with the specific to my particular app here. Even this could be a variable for my app ID, my reference app ID, but I'll leave it hard-coded for the time being. Probably still blowing up on maybe the auth type, which needs to be SSO. Endpoint name, that might be helpful. Call this get orc data. All right, now that I have that, let's go ahead and output this data somewhere so we can see what we're working with. So here in the text, I'm just going to put the value as org data, get org data, right? Dot data, and push the little code button. Get anything. Load. Actually gets data back, right? Build this one more time and test it so I'm not going crazy. Definitely returns stuff, so that's good. That means I have some sort of error here in my, probably my endpoint. Do a page inspect. We can take a look at what I was referring to with my PMD script here. Need to change this to a view page. Play. Your page inspector. Darn it. Get org data. Empty. Definitely just a get. Looks right. My data provider wrong? Orchestrate v1 apps. And my URL. Oh, double slashes. So my data provider is providing me a slash at the end of my URL. And so was my hard-coded value for the end of the URL. So I needed to get rid of one or the other. But it's still empty. Darn it. That might have been the problem. Does not seem to be. Not sure. In my page inspector. If I do 0 here. Try and just get the whole thing. This should come with a bunch of headers and stuff. There it is. Oh, I guess I didn't need to specify .data. Interesting. So got all my stuff coming back now. Now we just need to kind of create basically a grid around this and distribute it in a PMD. So that shouldn't be too terrible. But we are seeing our orchestration data coming through onto our little makeshift dashboard at the time being. So unfortunate that got a little road bump here in getting this going, but we are on our way there. We will pick this up again tomorrow, and I hope to see you guys all at the DPUC.